All right. And we'll get started. All right. So it is Tuesday, Thursday class. This is the second to last week of classes. They're in the fall. There are reading days, the Thursday and Friday of the last week of classes, which means there's no class next Thursday. So technically, we have Tuesday, Thursday of this week, today, tomorrow, today and Thursday, and just Tuesday of next week. 3 class days left. I originally planned for us to do.
No, I want it.
Nope. Don't need to turn your mic off. I originally planned for us to have a final exam. Normally with CS5, if this were the regular school year, we would have projects and a final exam. And my original plan, which I announced 2-3 weeks ago, was to skip the project and to cover new material all the way up to the last day of class and just have a final exam. I think I'm going to change gears actually on you all, and this is an attempt partly to make things easier for you and partly to make the class more interesting for you and a little more fun. I think I shouldn't say I think. We're not going to have a final exam. I'm not going to bother with a final exam, but we are going to have a project. And today will be the last day we will cover new material. And after today, you'll just have time to work on projects. I will continue to be online at this time next Thursday and next Tuesday to help you with projects. I will continue to be online during lab times and during my office hours. So you have access to me quite a bit. If you want to take advantage of that, if you want to just work on your own, that's fine as well. We will have one more homework assignment, which is beyond the material we're going to cover today. And then that's going to launch us into the projects. Now on Thursday, you should all come to class on Thursday, because on Thursday I'll talk more about what I expect for the projects. I'll kind of hint at the end of class today. Thursday we'll all meet at this time, and I'll go into detail about what I expect for the project, and then you'll have a week to do the project. It's not going to be a huge project because I'm only going to give you a week to do it. But it's going to build on some of the stuff we've been doing and on the stuff we're going to do today. I see there's something in the chat window. Michelle asked, are we currently on pass-fail for this class or still letter grading? No, everybody's been moved to pass-fail. I know there have been some requests for some people to have a letter grade, and I am considering those requests. I haven't gotten back to anybody about that yet, but it is something I'm considering. I have heard some pretty compelling individual stories, but overall, I'm pretty hesitant to grant those. But again, I've seen some good arguments out there for some individual people. Max said, does that include non-Pitzer students? Yes, it does. Everybody. Yes, I think the fairest thing. It's not really fair for me to move one set of students to pass-fail and not another set of students. So right now, I'm planning on just assigning a grade of pass or fail to everybody. But as I say, some people have emailed me some compelling stories, and I am considering those as reasons, legitimate reasons, to move you to a letter grade. Pitzer as a whole is considering a proposal to go to a universal A or fail. And I am going to be very hesitant to implement that if they pass it, and I suspect that will not pass. I think they're going to be considering that in a faculty meeting tomorrow. So I wouldn't get your hopes up about that sort of thing, even though that's what the students have been asking for. We did a survey of 200 liberal arts colleges across the country, and none of them went to universal A. It's not a popular idea across the country. And when we partly need to be consistent with what other liberal arts schools are doing. But again, that's something the faculty and students are debating at the moment. Some faculty are really on board with that. Okay, let's jump into it. So today again is the last day where we'll do new material, and that'll lead us to what I would expect of you for the projects, and then you'll have a week to do projects, and then we're going to be done for the semester. Okay. All right. So you should all be seeing my iPad screen now, and It says there, Python features motivated by Vpython. Okay, so Vpython is what we're all going to be learning. Vpython is, V stands for Visual Python. We've done some visual graphical things. You made a Connect 4 board by using ASCII2 art, just printing out individual string characters and making kind of a graphical representation of a Connect 4 board. Earlier, we did fractals, Mandelbrot sets. You did various ways to render images and create images. VPython is another way to get Python to create images. And the nice thing about VPython is you can create animations with VPython. And also VPython allows you to interact with Python. So as the user is running a VPython program, they can hit a key and VPython will detect that key press and report it back to the program. And if the programmer has set things up to detect the key press and do something, then that can affect the animation. So this introduces some interactivity, and this is how you can make video games. So we're all gonna make some very primitive video games. And that's essentially what your project is gonna be, is to program a video game, okay? So that should be, I think that'll be fun for everybody. And, but we gotta first learn how VPython works. Before we jump into VPython, one of the concepts in VPython that's going to be important is something we haven't learned about yet in Python, which is called a tuple. So we've learned about lists. Tuples are almost identical to lists. One of the only visual immediate differences is that if you have a tuple, you surround those with just regular old round parentheses, whereas when you have a list, you use square brackets. Functionally, they are going to be very, very, very similar. You can use list slicing with tuples. You can use indexing. You can refer to individual elements in the exact same way we did them with lists. But now we're going to do it with tuples. There are one key major difference between tuples and lists that we'll get to in a little bit. When you make a function call, down here at the bottom, you see this regular old function call, but it doesn't look like a function call that we normally do. Normally, when we define a function, we might do def and then f of x comma y. But what you see right over here, that's a tuple, okay? That's, as from math classes, you might be used to visualizing that as a list of the inputs of f, and that's exactly what it is. It's a list. So f is the name of the function you're about to define, and round parentheses, x comma y, round parentheses, that's a tuple. So when you feed a tuple, when you define a function, you always feed a tuple into that function, and you always get a tuple out of that function, although that's not always so obvious because you just have a return statement. You don't have parentheses typically around the thing you're returning, but it's technically returning it as a tuple. So these are examples of tuples, 4, 2. It's just a very simple example of a tuple. It just looks like a 2-element list. Here, this looks like a 3-element list. And again, there are times you're going to use tuples instead of lists. One obvious time is when you're defining a function. You'll always use tuples instead of lists in a function definition. There's some things to know about function definitions. This is almost an aside, which is that you can define default values within a function definition. So you're seeing right here this equals 3 and equals 17. This is something we haven't done before. Those are default values. So if the user calls that function and doesn't pick values of x and y themselves, then the computer will pick values of x and y for you, and the values they'll pick are 3 and 17 in this case. So the nice thing about defining a function using default values is it lets the user kind of be lazy. If the user doesn't actually care what inputs are used, they just want to run the function, they can just call this function. So if the user wants, the user can now just type f bracket bracket with nothing there, and the computer will automatically use the values 3 and 17 for x and y. Just a little bit more about tuples before we get back into function calls. Again, a tuple is just a list, right? Tuple just looks like a list. So there's a list with 2 things, 4 and 2, And if you, once you make this definition, if you ask it what t is, it'll tell you it's 4 comma 2. Again, you can use indexing and list slicing just like you would with lists. So if you ask for the 0th element of that tuple, it'll say the number 4. That's the 0th element of that tuple. Now, here's one of the big differences right down here. Normally with a list, if I say t is the list 4 comma 2, and then I say t of 0 equals 42, what that does is it redefines the 0th element of that list. Instead of 4, now it's 42. So now if I ask it for t, the computer will print out 42 comma 2. Okay? This is the big difference with tuples. Tuples are immutable. We've seen that word before. Right? A list usually refers to just a pointer to a memory location, and then you can change what's in that memory location by just reassigning things. Tuples, you should think of as just a whole object where you can't change any of the individual bits of that object. So if you try to reassign t of 0 to be the number 42, it'll give you an error. List tuples are immutable. They cannot be changed unless you just change the whole thing. So you could do this and change the whole thing and just assign the variable t to an entirely new tuple. But you can't change the individual elements of the tuple. Once they've been assigned, they're permanent unless you just trash the whole tuple and reassign it. Okay? Now, why would you ever want to do that? Well, that answer is down here in the bottom of the screen. We would want to do that because tuples are way more memory efficient and time efficient. And when you get into complex programming, memory and time are huge considerations that you're absolutely going to want to pay attention to. So if you're not going to be accessing the individual elements and changing them, then you probably want to use a tuple instead of a list. That'll be a lot more efficient and your program will run a lot faster. Okay, so it's just a difference in the way Python is set up. It's got these two different data structures, tuples and lists. They're very similar. One has the advantage that it is mutable and you can change the individual entries at the cost of memory and time. The other one is immutable. Those are tuples. You cannot change the individual entries and they're more efficient, right? So there's just pros and cons of each. Functions always use tuples as their input, as I said. And one additional feature that we hadn't really talked about before is that those individual entries can have default values. So if you call, if this is our function definition, and you call 4 comma 2, then it'll assign the number 4 to x and the number 2 to y, just as normal, and it'll ignore the 3 and the 17. Right, so this will just act like a regular function call, and you'll just get 10 times x, which is 4, plus y, which is 2, which is 42. Okay, exactly what you'd expect, even if that 3 and that 17 weren't there in the original function definition. But the nice thing about defining those default values is if you call the function with nothing, then those default values now kick in. Now x is 3 because that's the default value, and y is 17 because that's the default value. So we get 10 times 3 plus 17, which is 47. Okay, you could call this function with only one input, even though the formula that defines the function requires two things, an x and a y. If you call it with just one thing, then it'll take the place of the first input. So that 1 will get assigned to x, and y will continue to be the default value of 17. So we'd get 10 times 1 plus 17. So it'll return 27. Okay, so if you just define one of the inputs, it'll go to the first variable, and the other variables will just stay with the default values. Now, you might not want to do that. You might want to define the second variable and leave the first variable to be the default value, and you can do that, but then you have to be explicit that it's y you want to be um, not the default. You want y to be 1, and you want to leave x as the default. And so now you get 10 times 3 plus 1, which is 31. Okay. If there are questions about this, go ahead and just type them in the chat window or yell them out. I don't think this is too difficult to wrap your head around. All right, so quick little quiz here. You do it yourself. I'll give you 3 or 4 minutes. I don't think this is a terribly difficult quiz. Just run through these individual questions and see if you can get some answers there. Okay, just write them down on a piece of paper, or you could even do most of these in your head. I'll give you, I don't know, 3 minutes and we'll go over the answers. All of the questions refer to that function that's defined at the top of the screen there with those default values of 2 for x and 11 for y. Somebody's got their mic on. Who is it? I could probably tell who it is. Or I could probably turn your mic off. Oh, they turned it off. Thank you for those of you who are keeping your video on. It really does help me to be able to see some faces while I lecture. Even just like one person, just to know I'm talking to humans. All right, let's go through these real quick. F of 3 comma 1, so 3 becomes x, 1 becomes y. So we get x plus 3y is just 3 plus 3 times 1, which is 6. Anybody have any questions on that? Okay, the next one here, it's just you're not providing any input, so it's just using the default values of 2 and 11. So we get 2 plus 3 times 11, which is 33 plus 2, which is 35. Good. Okay. The next one, that 3 is going to become the first variable, which is x. Y stays the default value, which is 11. So we get 3 plus 3 times 11, which is 33 plus 3, which is 36. The last one we didn't really talk about before. Here we're redefining y to be 4 and x to be 2. They're out of order, but that's okay because we're being explicit about which is which. Okay, so y becomes 4, x becomes 2, so the formula is x plus 3y, so we get 2 plus 3 times 4, which is 14. Okay, hopefully you all got that. Remember, Python does dynamic typing. So in other languages, when you write a formula like x plus 3y, you have to tell it that x and y are integers or floating points or not. But with Python, it'll just try to make sense of things when it can. So if you want this function to return a string, then x and y should both be strings. So I think the right answer here is f of quote L-A-L-A, quote L-A. Whoops. So then we do 3 times y, which gives us la, la, la. And before that, we have la, la. So there's x plus y, y, y. X plus 3 copies of y is right there. When you do addition and multiplication, then you see there's a question in the chat. When you do addition and multiplication with strings, you know multiplication with strings just repeats it over and over and over again, and addition does concatenation. Livia asks, with tuples, is it necessary to set default values for the variables? No, no. Normally, when we define a function, we just, if you don't use default values, then you're just doing something like f of x comma y, and you just define your function without defining default values. Just fine. Okay. Okay, last one here. Oops. I hit the undo button too many times, and now my computer's reacting slow and erasing the last bunch of things I did. All right, last one there. What is S, so second last one, what is f of the empty tuple plus 3 times the tuple 1, 0? So again, tuples are just like lists. If I do a list plus a list, it's list concatenation. If I do a tuple plus a tuple, it's tuple concatenation. If I do 3 times a list, I copy that list 3 times and concatenate them all, run them all together. Same thing with tuples. So this is going to be the empty tuple plus 1, 0 plus 1, 0 plus another 1, 0. And that's going to give us a tuple, which is just 1, 0, 1, 0, 1, 0. Right? The empty tuple concatenated with anything is just itself. Okay. And then the last one there, what's the shortest call to f returning 42? I came up with f of 9. I don't know if anybody came up with anything shorter. F of 9, 9 would then become x, and y stays with the default value of 11. So we end up with 9 plus 3 times 11, which is 42. I can't imagine that there'd be a shorter one. We can't leave nothing in the parentheses because then we know we don't get 42, right? So we have to have something in the parentheses, and a single character entry in the parentheses is as short as you can get. So. All right, very last one. What does y, if y equals 60 and x equals -6, what is f of y equals x, x equals y? So this seems confusing, but again, I think it's this problem over here that really should shed some light on this. The y equals is what's telling the function what the function y is, and what in the definition of the function, for this number is what it's going to use for y, and this number is what it's going to use for x. So down here at the bottom of the screen, it's going to use -6 for y, right? That minus 6 goes there. And that, sorry, it's a little hard to use my iPad when things at the very bottom of the screen. That 60 is going to go there. And so we're going to get y is minus 6, x is 60, so we have 60 plus 3 times minus 6. 60 plus 3 times minus 6. 3 times minus 6 is minus 18. 60 plus minus 18. There's finally our 42 on this quiz. Megan asked, does the third to last one get multiplied out by the function, or does it remain as sets of numbers? So the third to last one, the answer to that one is right here. Hope that answers your question. It becomes one long set of numbers. You don't distribute the 3, you just take that tuple and copy it 3 times and then concatenate them all. Did that answer your question, Megan? Cool. All right. We already went over these. All right. So now that we understand tuples and default values, that's going to be a very important when we start calling functions in Vpython. Again, I'll repeat something that we said last time in class, which is that you've now learned, I don't know, maybe 60 to 70% of the Python programming language. You've learned a lot of the default Python programming language. There's still some technical things we haven't done that are a lot less common, but for almost all your Python, your programming applications in the future, you're in another class, you want to do something for that other class, and you think, hey, I can write a program to do this. You probably now know enough Python to do that. But Python by itself is not terribly useful. For example, Python by itself doesn't have a random number generator. It doesn't have a lot of math functions built in. Now you already know you can expand Python by importing libraries. So you can import the math library, and now you have access to hundreds of mathematical operations. You can import the random library, and now you have a random number generator, right? And you know maybe less than 1% of all the libraries that are out there. There's huge, huge numbers of libraries to do all kinds of things, to do data science, to do statistical inference, to do graphing, to do all kinds of things that are really unbelievable. It's really, really amazing. You don't have to learn any new kinds of programming structures. Python gives you a framework. Those libraries just contain new commands. Okay? And all those commands are usually in the form of imported classes and objects and methods. Right? So all that work we did on defining classes is really important to understand what it is that you're importing when you import a library. Okay? So for instance, if you say import math, math is just one giant class. And then you could use math.cosine. That's a method in the math class. It's the cosine method in the math class. Okay? So we've done all those things. You've seen already the random library. It's really just one giant class definition called random. And then you could say random.choice. Choice is one method in the random class. Okay? That dot notation is extremely powerful. So we're going to learn Vpython, which is just another library for doing visual interaction with Python. And it's cool because you can make video games. So it's super fun. It also doesn't run, though, on your regular old VSC Python 3 installation that you have on your computer. So you don't have, the good news is you don't have to install anything new, but you do have to have an internet connection. What we're going to do is we're going to write and run all our programs on a particular website that I'll point you to in a minute, and it'll execute those Vpython programs and show you the results. So these are all going to be, there's going to be some web-based programming, but it's just going to be Python written in a text editor in a web browser. rather than on your own computer. Okay, be easy enough. And I'm going to show it to you in a minute. Um, so this is what it looks like. We'll see some of these animations here. Um, there are two things to know. There's GlowScript. GlowScript is really the online environment where you're going to write and execute your programs. The language that you use at the GlowScript website is Vpython. So when you look for the Vpython documentation, you can just Google Vpython and you'll see it. I'm going to show you all of that in a minute. Okay. So actually, let me switch my screen now to GlowScript. Oops. Right there. Share. Okay, hopefully you're all seeing glowscript.org, right? If you just type GlowScript, then you should get to this website. I've already logged in, so you see at the top right, it's got my Gmail username. So if you have a Google account, you can just sign in with that, or you can create an account. So you're all going to have to create accounts at GlowScript for your next assignment, for your next homework assignment, and then you're going to do your projects here as well. Okay, so it tells me, it doesn't tell you a whole lot from the home screen. It says you're signed in as Dave Backman, your programs are here, and then there's also a bunch of example programs down here. Okay, so let me just show you a real simple program right here. It's a test program. So first I'll run it so you can see what it does. Okay, and there we just see it's just a ball bouncing. Right now, the cool thing about GlowScript, about Vpython, is that this isn't just animated object, it's three-dimensional animated object. So we can rotate this, and we're going to be making three-dimensional video games. So I'm holding down the right mouse button and moving this thing around. If you're just on a laptop and you have a trackpad, I know on my Mac, 2 fingers on the trackpad is what I use to scroll around. So you may have to play with the controls on your computer, and you should be able to just zoom around any scene that you create. Okay, I'll show you the program here. Just go to edit this program, and it's a super short program. That ball bouncing is this program here. It's 18 lines, a couple of the lines are comments, there's some spaces in there, so it's not a whole lot of text. And we see there's a couple different things. So floor is just an object that we're going to create, and we're going to create the floor object by calling the box function. So the box function creates a box, and here you're seeing a big tuple, and that tuple has 4 arguments, and each of those arguments have default values. So box has a length variable, and instead of the default value for the length variable, I don't know what that is, we're going to use the number 4. And there's a width variable, and we're going to use the number 4, and a height variable, we're going to use 0.5 for the height, and the color variable. Okay, now the color variable is another kind of Vpython object called a vector, right? So vector is another built-in function, and that built-in function also takes a tuple, and the tuple it takes has 3 numbers which are between 0 and 1, representing the amounts of red, green, and blue. Okay, so again, just going back to this program, that's what creates just that blue rectangular thing on the bottom, which is the thing the ball is bouncing against. Okay, just that one line of code. Right, now we've got to deal with the ball. The ball, we use the sphere function to create a ball. Okay, the sphere function has a couple of different inputs that have names to them. Just like in all those examples we did with tuple definitions where we had x equals 3, y equals 4, there's POS for position, or radius, and color. Those are the arguments for the sphere function, and you can set those to be whatever you want in whatever order you want, because we're doing it with names. So again, the position is given by a vector, A vector is another function that has 3 arguments for the x, y, and z coordinates. A sphere has a radius. That's just a number, and it has a color, which is also a vector, which is, again, a function that has 3 arguments, 1, 0, 0. You'll see as you go through these, the first time you see VPython, it may seem super confusing, but we'll go through lots of examples, and I'll show you the documentation, and you'll see there's lots of places for help. Ball.vel, now remember, ball, so let's see if we can remember all our language here. So ball is a variable we created. Okay, it is one instance of the sphere object, right? So we called the sphere function. Sphere function creates a sphere object, right? Now ball is an instance of that, okay? Now because it's an instance of something, it has its own methods. One of the methods of the ball object, sorry, not one of the methods, one of the attributes of the ball object is its velocity. VEL stands for velocity, and you can set that attribute to be a vector. And that just tells you the direction that ball is headed and the speed at which it's going. So it's going to go in the -1 units per second in the y direction. On your screen, when you see a thing, I'll show this to you. The y direction is what looks like it's vertical. So y is up and down here. X is left and right, and Z is the depth. The Z is actually pointing into the screen. All right, rate, that stands for frame rate. Okay, so if any of you have ever done anything with film or any kind of computer animation or anything, the way, or you've ever, when you were a kid, made a flip book. I hope you all know animation, the way animation works, it's just a visual trick. The way animation works is it's flashing pictures at you really, really fast. Each picture is a little bit different from the previous picture, and your eye and your brain interprets that sequence of pictures as movement, okay? Now, those pictures can be flashing at you at different rates, and so rate is a predefined variable that we're gonna create here that we're gonna feed into the rate function down here. And the rate function just tells you how fast to flash those pictures at you. And 30 means it's flashing them 30 times a second. 30 frames per second is really standard in animation to create smooth animations. Any less than 30 and your animations start to look really choppy. Any more than 30 and you may not notice it because your eye is sufficiently tricked at 30 frames a second to make it look like you're seeing smooth animations. Now what's going to happen, I'm not going to go through this whole program in detail, but the point is that every click of the clock, first of all, we're in a while true loop, right? While true means this stuff is just going to repeat over and over and over again. So this is what keeps redrawing the pictures over and over and over again, okay? What it's going to do is it's going to adjust the position of the ball based on the ball's velocity, okay? So if the ball's headed downward at 1 frame per second, or sorry, 1 meter per second, then it'll say in the next click of the clock, the position is 1 less. If the ball's velocity is going in the negative direction at 2 units per second, then what it does is it just subtracts 2 from the position, from the y coordinate of the ball, okay? This stuff down here is collision detection. We'll talk more about collision detection in a minute. It's saying if the ball's position is less than 1, well, 1 is the location of the top of the box at the bottom. So it's saying, this is saying right here is if the ball is below the level of the floor, then we got to reverse its direction, make it start going up instead of down. And that's exactly what's happening here. If the ball is below the level of the floor, then it's going to multiply the velocity by -1. So if the velocity were negative, it's going down, 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 down. We multiply that velocity by -1, now it's positive. So it's going to be going up, 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 right? So that's where we do the collision detection, right? These objects don't have any attributes. They're not actually solid things. They're just illusions to you. You have to make them seem like they're solids by detecting collisions, and when a collision happens, you've got to make sure they bounce off each other and do something, okay? If that doesn't happen, another nice feature of this program is that as the ball is falling, it's going faster and faster and faster. And as it's going up, it goes slower, 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 slower till it reaches that peak, and then it reverses direction, goes down, 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 down. And that's just one line of code here. The else command is it's saying if we haven't hit the floor, right? If ball position is less than 1, that means we've hit the floor. If we haven't hit the floor, then what we want to do is build in the effect of gravity so it seems like the ball is under the influence of gravity. So these are all just tricks. We are programming gravity. We're programming collision detection so that it looks to your eye like this is actually a physical ball bouncing under the influence of gravity, hitting that blue box and bouncing off of it, right? It's all just tricks. And you're gonna have to learn how to do those tricks yourself. And there's lots of hints and lots of sample files that you'll be able to copy. One of the most important things for you to know is script programs, is where the example programs are. So back at the GlowScript homepage, you'll see down on the bottom right, it says example programs. So if you go there, you see lots and lots of good examples of different things you can do. And the nice thing about all these examples is you can not only see them go, but also view the program. In the top left, you can view the program, and you'll get a lot of good ideas on how to do stuff. So it's a good idea to kind of run through the sample programs, look for one that does the kind of thing you want to do, and then look at the code to see how they did it, okay? It's a nice little example. If we go back to here, I'll just run through a couple of those. You can map pictures onto objects. There's some special code to do that. It's not very hard. So you can create really realistic looking objects by mapping a picture onto them. So for example, you could find on the internet a photo of a basketball texture. You can create a sphere object and wrap this basketball photo onto it to make it actually look like a basketball rather than just a boring sphere, right? So then again, that's not very hard to do. It'll take a little bit of research on your part to learn how to do something like that if that's what you want to do. By stringing together objects, you can make these kind of elaborate groups of objects. So there's a cylinder object here, an arrow object, a helical object making the spring, you know, and they've programmed this to look like it's some kind of machine or something to do something. You can add interactivity. So let's see. Down at the bottom, there's a more interactive one. Oh yeah, Vert Stonehenge. Let's run Stonehenge. So at first, Stonehenge doesn't look like it's doing anything. Now I'm gonna hold down the left mouse button toward the top of the screen, and I'm gonna go forward. As I lower my mouse down bottom, it goes backwards. So I'm now controlling this. And as I go left and right, I'm steering this. So you can, now this was programmed, right? So the programmer set things up so that I can navigate through as the user like this. And then there's just literally a bunch of random objects moving, doing random things, just to kind of highlight the kind of stuff you can do in Vpython. It's like some weird torture chamber or something. Let's see if there's any others I wanted to show you. No, I think I hope you have some ideas of the capability of some of the capabilities of Vpython now. And here's just a very mathematical one. Somebody made basically a 3D graphing calculator. This can be rotated, but I don't have anything else I can do except watch it just change the function that it's graphing. I did want to show you one other thing. Last year, students had a lot more time for projects. They also had different options for projects. They didn't have to do Vpython. Your project that you're going to do after the homework assignment is you're going to have to use Vpython, but it's going to be fairly primitive. And again, I'll give you more guidelines about that next Thursday. But I did want to show you what I thought was one of the best projects from last year. This was a student project from last year, one of the people in my CS5 class from last year. And He made this billiards game, and so the farther away from the cue ball I click, it creates a pool cue, and the longer the pool cue is, the harder the force it's hitting that ball with. And players, it's saying on the bottom who goes next, player one or player two. One of them is supposed to get the red balls in the pocket. One of them is supposed to get the blue balls in the pockets. The pockets are just these little cylindrical puck things in the sides. So he made it try to look as much like a pool table as he could. And as soon as something hits a pocket, then, oop, I scratched. Now it's a player two has lost because I got the white ball, the cue ball into the pocket. So he's trying to simulate some kind of billiards game where one of the players has to get all the blue balls in, the other one has to get the black balls in, and neither player can scratch and neither player can get the black ball in. I thought that was a really good project from last year. Somebody made a pinball game last year. So all you have is just a single mouse button that controls flippers at the bottom, and they just simulated, and the ball is just going up and bouncing around and colliding into objects. And when it comes back down, you have to hit the flippers at the right rate to get it to bounce back up, right? So these are, you can make any kind of project you want. And I encourage you to start thinking, this is pretty detailed. This took him 2-3 weeks. You only have a week. So you should think of, don't go nuts trying to think of like some elaborate, version of Space Invaders or some video game or something. Don't try to program Fortnite in Vpython. Just try to think of like the simplest game you can think of where there's some sort of concept of winning and losing. There's some sort of scoring. And again, I'll go through very specific guidelines for that on Thursday, okay? All right, one more thing. To understand Vpython, the most important thing is to know what functions are available to you in Vpython. So for that, I haven't found a link to that on the GlowScript website, but if you just Google Vpython, then Vpython is just a separate website, vpython.org, and you can go to documentation, and on the left, these pull-down menus on the left side of the screen is really where the documentation you want to go. So let's, for example, let's go to the documentation for the sphere object, which is down here. We already saw that in that ball bouncing program. And it's telling you, you can create a ball by calling the sphere function. The sphere function has has a lot of arguments. By default, the position is the vector 1, 2, 1. Right, so the x coordinates 1, the y coordinates 2, the z coordinates 1. That's the default value. And the radius of the ball by default will be 0.5. So if you don't change the position of the radius, you just call sphere, open, close parentheses, and nothing else, then it's going to just create a sphere with that default position and radius. But of course, then you can change the position of the radius. And if you put that position and radius in a while true loop, you can continually update its position every time the while true loop runs, and it looks like the ball is moving. That's how you get this animation, okay? And it tells you that this will produce the sphere at location 1, 2, 1 with radius 0.5 with the current foreground color, okay? Now there's other arguments you can add to this function that they tell you. There's the axis, which won't do much for the sphere. You can change the color by setting a different vector. You can change the opacity, the shininess, the emissiveness. Those are all things that'll change its appearance. The texture, I wouldn't worry about most of those things. Mostly you're just gonna be worrying about the radius and the position and maybe the color, right? Radius, position, color is probably all that you'll care about. For a slightly more complicated object like the box, you've got not just the position, but the length, height, and width. And also you can set the color. Okay, so here's the full documentation on that. And if you read through this, you'll see all the different features you can use with the box object. But basically, the most important thing is you understand what's at the very top of the screen here. This is how you create a box. You call the box function with a position argument, a length argument, a height argument, and a width argument, and possibly a color argument if you want. Okay, and then there's other ones. You can create an arrow. There's an arrow. You can create an extrusion object. I'll let you read about that. There's nice examples of that. There's one in particular I wanted to show you. You can create a text object. You can have like words, three-dimensional words floating across the screen. Right? For the text argument, for the text function, you have to tell it what text it is. So you just input a string, and that's the text that will be created. And then its alignment, its color, its position, etc. Right? So you have the positions down here, the alignment, what text it is, the height of the text, the length of the text. There's all kinds of features when you program, when you want text displayed to the screen, you have a lot of control over how big it is, what color it is, where it is, etc. Here we go. Compound objects. One of the things you can do is you can create one object out of multiple objects. So for example, to create this hammer up in the top right corner of the screen, that's really two separate objects, but you can glue them together and call them as just a single object. So the handle is a cylinder object. It's just a long, thin brown cylinder. Right? There's the size and the color. Okay. The head of the hammer is a box. Okay. There's its size, its position, and its color. It's gray. Okay. And then to create the hammer as one single object, you use the compound function. And all the compound function takes as its arguments is a list of the objects. So you just feed the compound function a list of individual objects, and now it is considered one object, and you can set its axis, which sets its orientation space. If you change that axis, you will change the orientation of all the objects that make up the hammer object, right? And then you can simulate this hammer moving and hitting something. Right, so I can't go through every one of these. Animation speed is something you'll probably want to read about. That's just this rate function. So again, if you say rate 30, that means you're going at 30 frames per second. Okay. So another way to say that is rate 30 means that the picture will refresh itself in 1/30th of a second. Right? That's what they're saying here. Rate 50 means that it will that between frames, it will rate 1/50th of a second. Okay? Probably rate 30 is what you'll want to stick with. Rotations, you can rotate objects. Object.rotate will rotate the object. Clone, you can create multiple copies of the same object. Right, so you're going to have to just kind of go through one by one and read through these. For more complex motions, not everybody's going to want to do this. But for example, let's say you had a ball bouncing across the screen and moving from left to right as you went. Well, maybe you'd want to program a sine function or something like that for the ball to follow. It's not actually a sine function, but you might want to use some math functions to do some computations. And Vpython has, you don't have to necessarily do import math. I think you probably could to get more complicated math functions, but you could just call these math functions that are already built into Vpython. So you don't have to import any other special libraries to use these math functions. Maybe one I'm seeing on here now that I'm looking at this is the random function. You might want to program some randomness, and if you, depending on, again, what you do when you get to your project, maybe there'll be some random elements to what's going on the screen, so you have access to this random function, which gives you a number between 0 and 1. If you want a number between 0 and 10, you just use 10 times random. That gives you a number between 0 and 10. All right, I think that's all I wanted to show you on the Vpython website. So let's go back to our slideshow and see if I missed anything. All right, so we're back. Great. So I had to realign my windows here. So we're back. So again, I've already shown you the GlowScript website and the VPython website. There's two different websites. You're going to write your code, and your project's going to be at the GlowScript website, but the documentation is at the VPython website. So you have to kind of go between both to see where things are. Again, this is just going through a lot of the stuff that I just showed you on that website. One of the things that it's a term you'll see a lot when you're using somebody else's software library is this term API. You may have seen this, for example, I'll give you an example. Twitter has an API. Facebook has an API. API stands for Application Programming Interface. So people write Twitter bots where they'll go and pull off the last 1,000 Twitter posts of Donald Trump, and then they'll analyze for every time he used a certain word, right? That it means you have to be able to write a program that interacts with Twitter. So you have to know some of Twitter's functions and methods and objects and attributes. And that's what the Twitter API is. It's just a list of the Twitter functions. Okay? They can't all be used with Python. You might have to use Java or C++ or something. So advanced programmers know a bunch of different languages so that they can use different APIs to do different functionality with web elements and whatnot. Okay, so what I just showed you is VPython's API, right? The application programming interface. All that means is I just showed you where the library is with all the functions that VPython understands that you will be able to use within your VPython code. You've got lots of things. I showed you a lot of these, right? There's the compound function to create a hammer. The box function creates a box. The clone function takes a predefined object and makes multiple copies of it. Okay, there's other things you can do that I haven't shown you. We saw sphere. We did not see pyramid, right? We did not see cylinder, but it's kind of obvious what that does. Helix, we saw one example where they made kind of a ball bouncing on a spring or something. That was just the helix function. But you got a lot of these different primitive kinds of objects that you can piece together to make more complicated looking things. So I've already showed this to you. Here's the help page on the box object, which you should read through the whole thing, but it's got an example at the top of the screen of how you would create a box. One of the things that we talked about that is important it's an important concept is the idea of a vector. A vector is going to be something that is an argument in a lot of the object functions. So for example, if you're creating a sphere, then you want to set sphere.position, and that'll be a vector object, which is a tuple representing the x, y, and z coordinate. So you'll feed a vector with x, y, and z into the dot position argument of your object. And that just puts the object at that position. Okay, I don't think it's too hard to get your head around this, but please do ask me questions if I've lost you. Right? What this sort of thing will do is it will change the position of an object according to its velocity. So it creates the new position by looking at the old position and moving it in the direction of some velocity vector. And that's how it's simulating movement. And if you had even a high school physics class, this should be pretty familiar to you. Vector object is worth looking at, but again, all you really need to know about the vector object is it takes a tuple, x, y, and z, and it creates a thing, an object, and that object is what you feed into other objects to set their position or their velocity or their color. Right? That vector object is important to understand because it's what you use to set the color for some other objects or set the position for some other objects. Arrows are another kind of object. Arrows are...
Wait, did you give science question?
Yeah, sorry. Arrows are another kind of object. They're just a single object. You can make an arrow yourself out of a compound object with a box and a pyramid, but you don't have to because arrows are a predefined object within GlowScript. So you might want to use arrows to do things. There are various vector functions that you can do. And again, if you had a high school physics class, these should look familiar. So for example, you can add two vectors and they add, the way you add one vector to another vector. Actually, adding vectors isn't even on here. I believe you can add two vectors, but I don't want to say that without that being in front of us. You can ask for the magnitude of a vector. That's just how long the vector is. So if you create a really long vector on the screen, and like in that billiards example I showed you from my student from last year, he wanted to create a pool cue that was a certain length, but then he also wanted to use that length to set the velocity of the ball that the cue was hitting. So he had to ask, how long is this vector I just created? And then use that to create the velocity of the ball, right? So he probably used something like this magnitude function. Magnitude just gives you the length of a vector, okay? And there's, most of you probably won't use most of these, maybe none of these, but if you have a math background or a physics background, all of these functions will look familiar to you. And if you're trying to simulate physics, then sometimes these vector functions can help. Again, the documentation is important to know where it is. You can just go through to, I guess the documentation you can find on the GlowScript website, but you could also just Google Vpython and you'll see all the documentation there on the Vpython website. Okay, we got 8 minutes left, and we just wanted to talk in the last 8 minutes about how you create collisions. Right? One of the things we want to do here is simulate physical objects. We have objects that are just, pixels on a screen, and to make them look like they're physical objects, to trick the user into thinking that these objects are actually solid and actually interacting with each other. One of the most important things to do is to be able to detect collisions and react to those collisions. So here's an example. We've got some sort of bumper on the screen, and we have some object going toward that bumper, and we want it to bounce off. Okay, so for example, if we have a line at position x equals 10, then what we do is we take our ball object, we move it in the direction of the velocity vector, and check its x coordinate. Okay, we keep moving it, check its x coordinate. Keep moving it, check its x coordinate. Once its x coordinate is greater than 10, in this example, right, because that's the direction of increasing x. So smaller x is to the left, larger x is to the right. So here, if we've hit that wall, we've actually gone through the wall a little bit. Right? Once we go through the wall and x is greater than 10, then we can erase what we just did very quickly, reverse course, and put a new ball in that position. Right, so this is typically the way collision detection works, is we calculate what our new position would be. Ideally, you don't even draw it there yet. You check in that new position, have we gone through some other object? If we have, then don't draw it, okay? Go backwards a step, change the velocity vector, and calculate the new position based on that new velocity vector. That's easy with a ball colliding against a line. It's not so easy with a sphere colliding against another sphere. So that's another kind of collision you might want to do, especially with that billiards example I showed you here. There you had lots and lots of balls all colliding against each other, okay? So if you want to do something like that, even just one ball colliding against another ball, you've got 2 balls total, and that's it. Then you've got to understand how to simulate spherical collisions in some realistic way. So the first approximation would be my ball's, the moving ball is moving, whoa, go back. first, here's the first approximation is what you're seeing in this picture, is your ball Q is moving, okay? When you see some overlap, then just stop Q, just make it freeze, okay? And make the red ball's velocity equal to what the Q ball's velocity used to be, okay? So just trade velocities. And what that'll look like is you have this blue ball, oops, you have this blue ball, and it's moving forward, moving forward, moving forward. It hits the red ball, it just stops in its tracks, and then the red ball moves off and now is over here, okay? That's not a very realistic looking collision, okay? But it's our first step. If we want to get a little more sophisticated, we can do this sort of thing, where again, we just stop Q first, it hits the two balls. If there's any overlap, we undo the overlap, right? So we test, did we go too far? If we did, we back up, right? That's what it means to undo the overlap, right? Q now just stops in its tracks, but the red ball moves in a direction that's determined by the difference between their centers. So you take the center of the red ball, center of the red ball, the center of the blue ball, you subtract those two centers to get this green direction arrow, and you use that direction arrow as the velocity for the red ball, okay? And now you let the red ball go at that velocity and it runs off the screen diagonally. It's a little bit more realistic. Again, if any of you have ever played pool or ever thrown a marble at another marble or whatever, you know that the blue ball isn't actually gonna just stop. It's gonna keep going as well. So the next approximation is you can do this sort of thing where we do what we just said for the red ball. So the red ball does go off in that direction, oops. But the blue ball, we calculate a vector that's perpendicular to D, right? That's this D perp vector right here. And we send the blue ball off in that direction. And that's what will actually happen if you were to shoot one ball at another ball. That's exactly what actually happens, is the red ball goes off in this direction that's determined by the difference in their centers, and the blue ball always goes off in a perpendicular direction. If you don't believe this, I think the first time I heard this, I was skeptical, but I also occasionally play pool, especially when I was in college. I was a big pool player because I lived in a house with a pool table. And there is a cool experiment. If you've never done this and you have access to a pool table, go ahead and go do this. Take a billiard ball, okay, and just lay it on the billiard table, and then take a second billiard ball so that it's touching the first one. And then take your cue ball, here's your cue ball, and just shoot it at the one of the two, okay? And it actually doesn't matter what angle you shoot it at. You can shoot it at one of the two. This is a great way to set up pool tricks. The black one will always move off in a direction that's determined by the difference of the centers, and the purple one will always move off in a perpendicular direction. You set it up right, always. So for instance, you can make a trick on a pool table, place a bet with a friend. Not that I've ever done this, of course. So you've had your pool table, okay, and it's got some pockets over here. And, whoa, go back. Sorry. No, forward. Damn it. Place one ball here, another ball touching it so that the two balls together are lined up with that pocket. If I draw a line between the orange one and the red one, I'll go right into that pocket. Okay, and now you put your cue ball anywhere on the table. It really doesn't matter where, anywhere on the table. You don't have to be a terribly good shot. If you hit that orange ball, the red ball will go in. It's a nice thing about this trick. Is like you really don't have to be a very good pool table player. If they are actually touching like that, that red ball will go in, because this is the physics of it. It will go off in a direction that's determined by the difference in their centers. It's worth reading about this online. The more you learn about physics, game programmers have to know a whole lot of physics. They have to understand Newton's laws and how collisions happen, and especially if you're going to program more realistic objects, like objects that are made out of rubber. You want to do some sort of elastic collisions. If you want to program a slingshot looking thing, you got to understand what the equations are that govern all that, because you then have to write those equations into your program to make those objects look like they're behaving realistically. Okay. And a lot of times these days, when people are talking about video games, you'll hear video gamers often talk about the game physics. How realistic is the physics of that game? And that's literally what they mean, is how good of a job did the programmers do just typing in the equations from a basic high school physics class. Usually that's all that you need is high school physics. Um, and you can get some pretty realistic looking behavior for the objects on the screen if the physics is done correctly. Your homework that's going to be due tomorrow, Thursday morning at 8 a.m. is just to do some really primitive stuff right now with VPython. Just, literally get your bearings. Just, go to the website, create an account, and then just, there's some starter code there that's in the homework assignment, and then work on creating a wall and creating wall collisions. And then when we get to the project, we're going to be thinking about this sort of stuff, adding things to it, adding some scoring, an adversary, moving targets, things like that. Don't start thinking about that now, because I'll have much more specific guidelines on Thursday. Some of the aspects of Connect 4 that we just talked about, I'd like you to use some of those aspects so that we kind of tie everything together. So everything we've done in the last couple of weeks is kind of building up to actually an interesting game that has some intelligence to it, where you have an opponent that has some intelligence, and yet also it has this sort of interactivity to it, like in an actual video game. Okay? All right. So good luck with your homework. And are there any last minute questions?
A question.
Yeah, Nick, go ahead.
Are we gonna do it said there was like extra credit for like the C4 like tournament, the Connect 4 tournament?
No, we're not going to do that.
No? Okay.
Yeah.
I'll just...
It'll be fun, but we're not going to do that. Yeah.
Okay.
Okay. Anybody else? All right. See you on Thursday. Bye.
Thank you. Thank you.